Welcome back to the Hack Lab podcast Safety Leadership Series, where we speak with experts who are driving innovation and shaping the future of workplace safety. Today's topic is technology and the future of fire protection. And joining me today is Mr. Renju Raj, Assistant Professor of Safety and Fire Engineering at the TOCH Institute of Science and Technology, CFD researcher, and certified safety trainer. With expertise spanning fire engineering, computational fluid dynamics, industrial safety, and engineering education, he brings a unique perspective on how emerging technologies are changing the way we predict, prevent, and respond to fire incidents. Sir, welcome to the show.
Thank you. Thank you so much. Thank you for having me again.
Yes, sir. So, before we get down to the questions, I would just like to understand from you your passion. How did you get into this safety engineering domain?
Okay. So, yeah, thank you once again for having me. Uh, so, my interest uh, comes in understanding how this fire protection can be effectively used. I mean, it is not just about controlling a fire once it is occurring. But if you have the right technology or the kind of training or the awareness, you can actually predict it or prevent and identify the early risk, plan accordingly, and then give proper training to people. So that is why where technical knowledge or engineering knowledge or something like simulations and
Mhm.
training can really help people and achieve their goals. So that is what interested in. That is what created interest in me
Mhm.
in exploring safety in a more detailed way.
Right, sir. Okay, so let's get started. Fire protection has evolved significantly over the past few decades.
Mm.
From your perspective, what has been the biggest technological advancement that have changed the way we approach fire safety?
Okay. So fire safety has definitely evolved over the last few years. Like earlier, if we say we had basic fire or maybe alarm systems, then the basic equipments, firefighting equipments, and some manual inspections, etc. But now we have sophisticated sensors or other detection systems, automatic suppression systems, smart sensors, etc. These can detect early things or predict
Mhm.
something before
Mhm.
even happening. So we have the technology that can drive us forward and give valuable insights before something chaotic or something drastic happens. So what essentially we are bringing here is we can plan. We can
Mhm.
plan, and this will also be a benchmark for something that we design in future. Okay, so we are definitely improving each year, each day,
Mhm.
so that in that way, these new technologies can bring in a better, safer design that we can implement in the future. Yeah.
Right, sir. So let's talk about some artificial intelligence as it is becoming a
Okay.
part of many safety systems. So,
Yes.
how do you
Yes.
see AI improving fire detection,
Mm.
risk prediction, and emergency response in industrial and commercial environments?
So AI or artificial intelligence, it is happening. It is integrating in every field, and safety is obviously one of the areas where AI can contribute well. So the good point about AI is that it is continuously getting data from whatever sources. I mean, real time data from say we can say some cameras or sensors. So they are predicting based. They are not simply just predicting things. So they are predicting the things, or they are identifying or recording based on some database which is already they are received. So they can recognize unusual, like for example, they can recognize unusual a heat or a smoke or a gas leakage, etc. It can also predict what areas are more vulnerable, and accordingly they can plan something like the escape routes,
Mhm.
and also enable this safety team or rescue team to have a faster decision making, etc. So
Mhm.
AI is definitely the technology is definitely supporting the professionals. So what I would suggest is we have to use them, and you cannot replace them for a trained professional. We have to, these two technologies has to go in hand. That is the trained
Mhm.
professionals as well as these modern technologies.
Right, sir. So, modern buildings are becoming smarter with IoT-enabled sensors and connected safety systems. How can these technologies improve fire prevention compared to the traditional fire protection systems?
Okay, so IoT is the Internet of Things. Here also, these are also new technologies. So they also communicate with each other. I mean,
Mhm.
for example, if you take a building or a facility, there's a temperature sensor, there's a smoke detector, there's a fire alarm system, and there's a control room. So data from all these things are getting fed into the system. That
Mhm.
is the real-time data. So, see, what all things I said, all these will give a holistic picture. So, the operator or the person who is analyzing these data get a whole picture, not just a picture from one side. So they
Mhm.
communicate with the entire system, and so we, in simpler terms, we get a better understanding of what is exactly happening, maybe inside the building or inside the facility, etc. So this again, like we said in the case of A, this again IoT will also help in identifying problems such as overheating, or maybe a gas leakage or a smoke detection even before a serious fire can occur. So that way, this
Mhm.
is also it is now moving towards prevention or a
Mhm.
proactive approach in safety. So all these technologies, AI, CFD, IoT, etc., these all contribute to a proactive approach in safety, and that is based on real-time data, not just some assumptions and then predicting this can happen, this can happen. No, that is not. That is why this technology, cutting-edge technology, is gaining importance. So they have a proper database, and they are giving us some suggestions or some decisions based on valid real-time data. Okay.
Right, sir.
So
Mhm.
in the case of, for example, maybe in if it is if the technology is not there, there can be chances of maybe partiality or our own misjudgments, etc., may happen. So
Mhm.
to some extent, this technology can drive us to help identify the system in early, and so that we can plan before something serious or something drastic happen. Yeah.
Okay. So, computational fluid dynamics (CFD) has become an important tool in the fire engineering. How does CFD help engineers understand fire behavior, smoke movement, and evacuation planning before the building is being constructed?
Yeah, CFD. CFD is myself being a CFD enthusiast. Yeah, CFD is definitely a great tool in which so CFD stands for computational fluid dynamics. What it basically tries to solve is the basic what you call basic conservation laws. That is the conservation of mass, momentum, and energy using
Mhm.
some Navier-Stokes equation or whatever equations, etc. So I'm not going into the detail. So what in the case of fire safety, what is more essential is you can actually visualize things like a smoke propagating through a building or a fire propagating through a building. So accordingly,
Mhm.
you can plan the escape routes, and you can also have like some permutations like how the temperature is going to increase. how much people are there. I mean, how much people may have to evacuate. So the engineers or the designers can essentially plan all this before constructing an actual building,
Mhm.
and design a ventilation system or a smoke control system and escape route according to the what the CFD. So basically, you will have to have high-end computational cost will be there because high-end systems will be required. But when you see with the actual facility being constructed, that cost can be it can be reasonable when you compare it with an actual expense and a
Mhm.
computation cost. Definitely, you will get an idea, like all these technologies like IoT, AI, CFD, etc.
Mhm.
So that tools nowadays, we the curriculum itself is being designed like that. We are including more software or simulation topics like CFD, AA,
Mhm.
and all this is already being integrated into the courses.
Right.
Yeah,
So, sir, what I understand is we are doing modeling, and in that we have different factors like the wind speed, the windows, the exit
yeah, yes,
route, and everything. And then we put fire in some place and observe how it spreads everywhere. And based on
yeah.
that, we are detecting the escape routes and where do we need
Hmm.
sprinklers and everything. Is that correct?
Yes, that is the most simplest way in which you can put it. I mean, there will be multiple factors contributing, like you said, wind is a and the heat or the moisture content. All these factors will be there, and we put this in a 3D, I mean, computational domain, and we observe as the time goes. Time is the variable. So as it goes, how this fire gets spread across the building
Mhm.
or across the facility, etc., and then try to optimize how we can control. So there are various other parameters, optimization parameters, and yeah, that is the simplest way in which we can put. But in the background, there are so many other things that is running.
Mhm.
Yeah. Okay.
Right, sir. So, sir, one more thing I was thinking, like theoretically and scientifically, this is very good. But in practical terms, is this
Mhm.
being deployed? Are there companies who are deploying this for real projects?
Yes, definitely, because what they have, of course, the most authentic data is real. I mean, the experimental data that is obviously there. But these softwares like numerical investigations will give us an idea that if all factors are set to the right way or the right assumptions are made. Assumptions are also very important. Right assumptions are made. We are going to expect this result. So
Yeah.
that is one
But
pre-information that you already have.
are people paying for this?
Yes, obviously that for example, an aircraft company like Boeing or some other Airbus, they won't be going for full scale production in the beginning itself. They will first analyze a
Mhm.
simulation or a modeling, model these things, put it into what you call the aerodynamic, the wind tunnel test. Okay, so in every field, that is just an example. So especially in the fire or safety field, everything. Fire and safety means everything is like a destructive testing, right? You will have to build the facility and destruct it. Basically, fires are all destructive in nature. So why not have a computational modeling where
Mhm.
you get a data and then later on, yes, you can go for the validity check. That is also necessary.
Right. I
But with
understand.
the
Like
advent of
Boeing.
the most modern computational facilities or technologies or the very efficient computers that we have, definitely it is. Earlier days, it was very time consuming. It was very expensive. Technology of the computers that we have, we get almost reliable results, which is dependable. Yes. But then, as I
Mhm.
said, the assumptions has to be right, the parameters has to be set right. So one thing that commonly we say about this numerical technique is garbage in, garbage out. So if you put the wrong inputs, you will get the wrong result. So that is very important. The
Yes.
expert has to put in the right factors and what is needed to obtain the result.
Right. I was thinking that conceptually and theoretically, I mean, this is a very strong way of designing and protecting the buildings and any industrial area before, we are predicting that if fire happens, how everything will work out. But I think in India, or for designing, I don't know, buildings or apartments, I don't think this technology is being used currently.
Like FDS, you might have heard about FDS software, Fire Dynamic Simulator. That is a kind of simulation software.
Okay.
That is kind of CFD software, etc. And there are very many others also. FDS is one of the important softwares. FDS, Fire Dynamic. I think it's Fire Dynamic Simulator.
Okay. Understood.
CFD means it is basically fluid dynamics, but then you can apply it for fire heat transfer also, because any fire, it is causing overheat and then causing the fire. So heat, I mean the heat transfer, fluid mechanics, the cooling systems, all these the small even the chip level small cooling systems that we have in our mobile phones, or chip the cameras, etc. So all these are undergoing the simulations first, and then only people are investing in real time. I mean, the experimental validation. Of course, still I say that experimental results are the primary or the last level, or those which can depend upon. But still, computational results, or people working in computational fields, or these kinds of simulation softwares are increasing, and that is also showing a very good trend. Just because of the reasons that I mentioned earlier, like you can without even restrictive testing, or investing many crores of rupees in building the facility, you can have a check in your modeling softwares, etc. Simulate the same environment with the same kind of conditions, factors, etc.
Yes.
Yeah.
So we are also seeing the emergence of drones, robotics, and autonomous systems in emergency response. What role do you think these technologies will play in protecting firefighters and reducing the response time?
Yeah, drones, obviously, yeah, drones, you see, they also go to these areas where the main advantage that I see is we can reduce the risk of risk to human life. That is those areas where you cannot send a person for firefighting. These drones can be employed in critical areas. They not only provide real-time images or thermal images or photos. Not only that, some drones can even extinguish or fight fires with the facilities that is already available in them. So in that way, especially in some if in some refineries, I think drones are being still employed in fighting fires, etc. So yeah, definitely there is a broader scope in employing them in protecting the system, etc.
Right.
Not only protecting the system, but also getting valuable informations. Like they all will be having a camera. Obviously, there will be camera and some sprinkler systems or nozzle systems for them to evacuate the fire. So the main thing here is we can preserve or save the precious human life, not risking them by sending them into those intricate areas.
Right,
Yeah.
sir. So while the technology continues to advance, human behavior remains a critical factor during emergencies. Can
Yeah.
technology
Yes.
ever replace the fire safety training, or will people always remain the most important part of fire protection?
See, No, actually, that the straight answer for that is no. Technology cannot replace people, because see, people, we still do not know how the people will respond to a situation. Right? People can get
Mhm.
panic. Okay, they can get confused. So proper training is still necessary. Only the technology can improve the systems, etc., but we need
Mhm.
to make people aware how to respond in a situation, or equip them for emergency preparedness, etc., and maybe train them for the proper use of firefighting systems, etc. So technology, yes, it is required, but still the training and awareness has to go, and these two has to go hand in hand.
Mhm.
Because for the simple reason that I said, people may get panic, they may get confused. So whenever a real emergency situation arises, these all things are possible. So technology has a limit there. So regular trainings or drills has to be there, and that should go in coordination with the technologies that is being used. So never, I don't think technology can ever replace the proper training or trained personnel, etc.
Right. So, okay, so many organizations are interested in adopting advanced fire safety technologies, but often struggle with cost, implementation, and maintenance. What practical advice will you give to organization planning this transition?
Okay. So what I suggest is every organization, every technology may not be suitable for your organization. That is first thing that you have to understand.
Mhm.
And same thing, just because the technology has newly arrived, you need not need to jump into that to invest in that. First, you need to study what is the present situation at your industry or at your facility, and what does this new technology offer? Is it viable? Is it compatible with the existing system? So, more than jumping into an investment, you have to make the study whether it is going to be viable. And just because you have a technology doesn't make it is just enough.
Mhm.
You have to train the people. You have to make arrangements for the system to get compatible with the new technology. So after all these preliminary or maybe a pilot study, then only invest in a new technology. After all, a sophisticated system is not useful if nobody in the company knows how to handle it or how to use it. So
Yes.
that has to be so the baseline, you have to consider the maintenance, you have to consider the staff
Mhm.
training, the system
Mhm.
testing, and also the compatibility.
Yes, sir.
So
Yes.
that way you can just hold on, check whether is it really necessary for the industry, because every
Mhm.
technology, as I said, may not be useful for every industry.
You're right.
Yeah.
Yes, sir.
Yes.
So, sir, looking ahead, what emerging technologies excite you the most in the field of fire protection, and how do you think it will influence fire safety over the next 10 years?
So all the technologies that we just discussed, like you have the AI, IoT, and CFD, drones. All these are the emerging technologies. As I said, the courses are being framed to
Mhm.
integrate this into every field, maybe in robotics, in safety, in mechanical engineering, chemical engineering, process design, everything.
Mhm.
So we are moving towards reacting to a fire, from reacting to a fire to predicting that
Mhm.
something is going to happen, or this much amount of casualties will be there. So we can predict some abnormal situations or scenarios in advance and alert the people. So in this way, we will be ready. The system will be ready, equipped for a disaster if it happens. And also the training. Not only the technology, the training has to go. People has to be trained. People has to be right awareness programs has to be done. Human supervision has to be there. Technology should always be supervised by a human or a worker, so that technology and this the training or the worker goes in rhythm.
Okay, sir. So finally, what advice would you give to young engineers and young
Hmm.
fire safety professionals who want to build career at the intersection of technology, innovation, and fire engineering?
Okay. So yeah, as a academician, I would say that first of all, you need to have a basic understanding of the science of fire or the fire safety science, the physics or the basics that is happening. There is chemistry involved. There are so many physics involved. So first of all, you need to have a thorough knowledge about the chemistry or the basic science, fire safety science, to be precise. That is happening in background. And then I would suggest people to invest more. Look into these simulation softwares that are available, like learning a skill in CFD, or some simulation softwares or modeling, etc., where you can literally see how this is happening, how this is going to influence all the other factors, etc. Then probably I would say attending a proper drill or a training, or a real-time exposure in a disaster scenario, or like for example, you take up a valid project in fire safety, or attend regular audits, conduct audit, okay, and training programs, etc. So in these three dimensions, first you have to have the basic knowledge or a in-depth knowledge of the science, then acquire some skills like you have CFD, FDS, or any simulation software, and also have a real time, a ground knowledge. If possible, attend a training session or an audit schedule, etc. So what young people, and this is how I would suggest young people who have interest in this safety and fire engineering or fire safety technology, etc. This would give you a broader picture, a holistic, a holistic thinking of this beautiful field.
Thank you, sir, for sharing your valuable insights and experiences with us. As
Thank you.
technology continues to evolve, the greatest challenge will be ensuring that innovation enhances safety while keeping people at the center of every decision. Thank you once again for joining us on the Hagla Podcast Safety Leadership Series. We will be back soon with another conversation featuring industry leaders and innovators shaping the future of safety. Until then, stay safe, keep learning, and have a wonderful day. Take care and have a nice day. Bye bye.
Thank you so much. It was nice talking to you. Thank you so much.